Hi students, good afternoon everybody. Today we are going to see plane. Plane is a surface. Plane is a surface such that the line joining any 2 points on it lies entirely on it. Means, suppose if we have the surface like this, this is a surface. If we take any 2 points on it, this is point A and this is point B here. And if we join the point A and B, then the segment AB, line segment AB lies totally, entirely in this surface. So such surface is called a plane. Whereas, see, if we have a surface like this surface, if we take any 2 points here, this is point A and if this is point B, and we join point A and B, then the line segment AB does not lies totally on the surface. So this surface is not a plane, whereas this surface is plane. Now if this we consider a circular surface like this, and if we take any 2 points, the point may be here and here, and if we join these 2 points, then this segment, this line segment lies totally on the surface. So this surface is also a plane, whereas this surface is not a plane. So plane is a surface such that the line joining any 2 points on it lies totally or entirely on that surface. So such surface is called a plane. And now today we are going to see the equation of plane. Equation of such surfaces means equation of plane. So let's see the equation of plane. So first theorem, the equation of plane passing through the point, the equation of plane passing through the point A with position vector A bar and perpendicular to vector N bar is, and perpendicular to vector N bar is R bar dot N bar is equal to A bar dot N bar. So let's see the proof of this theorem. See, we have to find out the equation of a plane passing through the point A with position vector A bar and perpendicular to the vector N bar. See, perpendicular to the vector N bar means if this backboard is a plane, then the vector which is perpendicular to this board, this vector, this is N bar, and this vector N bar which is perpendicular to the plane is called normal to the plane. So the vector which is in the direction of this plane is normal to this plane if the plane is this blackboard. Okay, so see, so consider the plane passing through the point A with position vector A bar. If this is the plane, this is a plane which passes through the point with position vector A bar. and to this plane the perpendicular vector is n bar. Means n bar is normal to the vector. So consider a plane passing through point A with position vector a bar and perpendicular to vector n bar. So n bar is normal to the plane, n bar is perpendicular to the plane. Let point P with position vector r bar be any point on the plane. Means point P with position vector r bar is a variable point, be any point on the plane. So if this point P is here, this is the point P with position vector r bar. Now join AP, join AP. So if you observe the figure, then this AP bar lies in the plane, and to this plane n bar is perpendicular. So n bar and AP bar are perpendicular to each other. So therefore AP bar is perpendicular to n bar. AP bar is perpendicular to n bar. So as AP bar is perpendicular to n bar, the dot product of AP bar and n bar is equal to 0, because we know that if any two vectors are perpendicular to each other, then their dot product is 0. So AP bar is perpendicular to n bar, so AP bar dot n bar is equal to 0. So as AP bar is equal to position vector of the point P, that is r bar, minus position vector of the point A, that is a bar, its dot width n bar is equal to 0. Now distribute this dot product. So it is r bar dot n bar minus a bar dot n bar is equal to 0. That is r bar dot n bar is equal to, shift this minus a bar dot n bar to right hand side. So r bar dot n bar is equal to a bar dot n bar, and this is the vector equation of a plane passing through the given point and perpendicular to the given vector. If in the remark, see here a bar is given, n bar is given, so a bar dot n bar can be found. So if a bar dot n bar is equal to D, then the equation of plane r bar dot n bar is equal to a bar dot n bar takes the form r bar dot n bar is equal to D, because a bar dot n bar is equal to D. So this is the vector equation of plane passing through the given point A with position vector a bar and perpendicular to the vector n bar. Now let's see the Cartesian form of equation of plane. So this is theorem 2. This is nothing but the Cartesian form. The equation of plane passing through the point A with coordinates x1, y1, z1 and direction ratios of whose normal are A, B, C is A in bracket x minus x1 plus B in bracket y minus y1 plus C in bracket z minus z1 is equal to 0. So see, we have a plane passing through the given point, and also we have the direction ratios of normal to the plane. So see here, this is the plane and this is the normal n bar which is perpendicular to the plane, and the plane here, the plane passes through the point A which coordinates x1, y1, z1. So let P which coordinates x, y, z be any point on the plane. Suppose that point P is here, whose coordinates are x, y, z. If we join AP, then that segment AP which lies in the plane, and that segment AP passes through 2 points, that is AX1, Y1, Z1 and PXYZ, and we know that if we have any 2 points on the line, then we can find the direction ratios of that line. Now here AP passes through 2 points A and P whose coordinates are known, so we can write the direction ratios of AP. Direction ratios of AP are x minus x1, y minus y1, z minus z1. Because if the line passes through ax1, y1, z1 and bx2, y2, z2, then the direction ratios of that line are x2 minus x1, y2 minus y1, z2 minus z1. The direction ratios of normal to the plane are A, B, C. The AP is perpendicular to the plane. Means AP is perpendicular to the normal, because AP lies in the plane. The normal is perpendicular to the plane, so normal is perpendicular to AP. And we know that we have one of the property, if we have two lines with direction ratios A1, B1, C1 and another line with direction ratios A2, B2 and C2, and if these two lines are perpendicular to each other, then we have the formula A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Now here AP has direction ratios x minus x1, y minus y1, z minus z1. Normal has direction ratios A, B, C, and normal and AP are perpendicular to each other. So therefore we have A into x minus x1 plus B into y minus y1 plus C into z minus z1 is equal to 0, and this is the equation of plane in Cartesian form. This is the equation of plane in Cartesian form. Remark. This equation of plane can be written as, the above equation can be written as ax plus by plus cz is equal to d. This equation can be written as ax plus by plus cz is equal to d. Okay, we have seen two theorems. In first, the equation of plane in vector form, in which we have seen the equation of plane passing through the given point and perpendicular to the given vector, and in the Cartesian form we have seen the equation of plane passing through the given point A, x1, y1, z1, and direction ratios of whose normal to the plane are A, B, C. So we have seen two forms, vector form as well as Cartesian form. Now let's see the examples on these two forms. Find the vector equation of plane passing through the point having position vector. Find the vector equation of plane passing through the point whose position vector is I cap plus j cap plus k cap and perpendicular to vector to vector n bar, and that n bar is given here perpendicular to vector 4i cap plus 5j cap plus 6k cap. ठीक. See here the point through which the line passes is given, means position vector of that point is given, and that is I cap plus j cap plus k cap, and the vector which is perpendicular to our required plane is also given, that is 4i cap plus 5j cap plus 6k cap. It means that here a bar is given and n bar is given. So, and we know that the vector equation, just we have seen, vector equation of plane passing through point A with position vector a bar and perpendicular to n bar is r bar dot n bar is equal to a bar dot n bar. Now here, see, here a bar is equal to I cap plus j cap plus k cap, n bar is equal to 4i cap plus 5j cap plus 6k cap. So to write the vector equation, we must have to find out a bar dot n bar. So a bar dot n bar is equal to I cap plus j cap plus k cap, it's a dot with 4i cap plus 5j cap plus 6k cap, and so which is equal to 1 into 4 plus 1 into 5 plus 1 into 6. So this is 4 plus 5 plus 6 and it is equal to 15. So therefore the required equation of plane is equal to, see, r bar. Required equation of plane is r bar dot n bar. What is n bar here? 4i cap plus 5j cap plus 6k cap is equal to a bar dot n bar. But what is a bar dot n bar? 15. It is equal to 15. So this is the required vector equation of a plane. Next example. Find the Cartesian equation of plane. Find the Cartesian equation of plane passing through the point passing through the point A with coordinates -1, 2, 3 and the direction ratios of whose normal are (0 to 5). See, second theorem, we have to make the use of that second theorem. We know that the equation of plane passing through the given point, the equation of plane passing through A, x1, y1, z1 and direction ratios of whose normal are A, B, C is, it is A into x minus x1 plus B into y minus y1 plus C into z minus z1 is equal to 0. Now here only we have to write x1, y1, z1 and ABC. Here, what is A, x1, y1, z1? x1, y1, z1, that is -1, 2, 3. And A is equal to 0, B is equal to 2 and C is equal to 5. So therefore, the equation of plane is, see, A in bracket, what is A? 0 in bracket, x minus x1, what is x1? -1, minus minus become +1, plus B into 2 into y minus y1, what is y1 here? 2, y minus 2, plus C, what is C? 5 in bracket, z minus z1, z minus z1 is 3, so 3 is equal to 0. That is 0 into everything goes to 0, so this is 0 plus 2 into y, that is 2y minus 4 plus 5z minus 15 is equal to 0. That is 2y plus 5z, see, -4 minus 15 minus 19 is equal to 0, or this can be written as 2y plus 5z is equal to 19. So this is the Cartesian equation of plane passing through the given point and having direction ratio 0 to 5 of his normal. So this is the vector equation of, this is the Cartesian equation of plane. So let's see next example. Find the Cartesian equation of plane passing through the point A. Passing through the point is given here, A, 7, 8, 6 and parallel to XY plane and parallel to XY plane. So see, let's see the example. Find the Cartesian equation of plane passing through the point A with coordinates 7, 8, 6 and parallel to XY plane. Means our required plane is parallel to XY plane. Our required plane is parallel to XY plane. We know that the equation of plane, in particular Cartesian equation of plane passing through the point A, x1, y1, z1 and direction ratios of whose normal are ABC is A in bracket x minus x1 plus B in bracket y minus y1 plus C in bracket z minus z1. Now in this example, A, x1, y1, z1 is given Now ABC are not given, normal is not given, it is only given that the plane is parallel to XY plane. Now plane is parallel to XY plane and normal to the XY plane is Z axis. Normal to the XY plane is Z axis, and we know that the direction ratios of Z axis are 0, 0, 1. So the direction ratios of normal to the XY plane are 0, 0, 1. So plane is parallel to XY plane. So Z axis is perpendicular to the plane. So normal to the plane is Z axis. So the direction ratios of normal are 0, 0, 1. So only we have to write it here. Here A x1 y1 z1 is 7, 8, 6. The plane is parallel to XY plane. Plane is parallel to XY plane. The normal to the XY plane has direction ratios. 0, 0, 1. So therefore the direction ratios of normal to the our required plane. Therefore the direction ratios of normal to the required plane are 0, 0, 1. So therefore A is equal to 0. Direction ratios of normal to the plane are 0, 0, 1 means ABC are 0, 0, 1. So A is equal to 0, B is equal to 0 and C is equal to 1. And so therefore the equation of required plane is, see what is A? What is A here? 0 in bracket x minus x1. So it is x minus 7 plus B. What is B? 0 in bracket y minus y1. Y1 is 8 plus C. What is C here? 1 in bracket z minus z1. Now z1 is here 6 is equal to 0. That is 0 into this thing goes to 0. This is 0. So it is z minus 6 is equal to 0, or this is z is equal to 6. And this is the equation of required plane. Let's see next example. The foot of the perpendicular drawn from origin, the foot of the perpendicular drawn from origin to the plane is M100. Find the vector equation of plane. Full stop. Find the vector equation of plane. Find the vector equation of plane. The foot of the perpendicular drawn from origin to the plane. Suppose if this is the plane, if this is your required plane, and if this is origin O, whose coordinates are 0, 0, 0, then perpendicular drawn from this point to the plane is M. This is the perpendicular, and that M has coordinates 1, 0, 0. Find the vector equation of plane. See, now OM is normal to the plane. Point M lies on the plane, so the plane passes through the point M, means normal is known, the point on the plane is known, so we can find the equation of plane in vector form. So let OM be the normal to the plane. M is 1, 0, 0. So therefore OM bar is equal to, OM is normal, so OM bar is N bar, and it is equal to I cap plus 0 J cap plus 0 K cap. Now the point M lies on the line, lies on the plane, so the point M has position vector, therefore the point M is foot of the perpendicular, so therefore M lies on the plane. So position vector of the point M, that is suppose small a bar, so therefore here small a bar or point M with position vector a bar, or if you directly write a bar, that is here a bar is equal to I cap plus 0 J cap plus 0 K cap. So the vector equation of plane, the vector equation of plane is, you know that it is R bar dot En bar is equal to A bar dot En bar. That is, En bar is here, I cap plus 0 J cap plus 0 K cap, and A bar is also 0 I cap plus 0 J cap plus 0 K cap. So it is R bar dot I cap plus 0 J cap plus 0 K cap is equal to A bar, that is I cap plus 0 J cap plus 0 K cap. Its dot with N bar. N bar is again I cap plus 0 J cap plus 0 K cap. That is R bar dot I cap plus 0 J cap plus 0 K cap is equal to, take the dot product of these two, so it is 1 into 1 plus 0 into 0 plus 0 into 0. That is R bar dot I cap plus 0 J cap plus 0 K cap is equal to 1 into 1 1 plus 0 plus 0. So therefore it is R bar dot I cap plus 0 J cap plus 0 K cap is equal to 1, and this is the required vector equation of plane. Or if you don't want to write this, you can write it as R bar dot I cap is equal to 1, simply like this. Okay, so today we have seen the vector equation of plane and Cartesian equation of plane. Okay, today we stop it here.